All right, I think this is recording. We'll find out. All right, so Lauren, this is an explanation of yesterday's homework questions. Okay, so we went through transcription and translation in class, but you needed to use this mRNA codon chart to answer the questions below. Okay, so number one was not worded in the best way. That's my fault. But for this question, I wanted you to tell me how many amino acids were coded for by this specific DNA sequence. Okay, so looking at our DNA strand, I don't have the answers filled in, but you should have gotten that it coded for 3 different amino acids. Okay, so the answer there was 3. Now, some people also interpreted this as how many amino acids are coded for in general. And if you did that, you could have counted up all the amino acids on this chart and gotten that the answer is 20. So there are 20 different amino acids. All right, number 2, what protein does this code for? So if you followed all these instructions correctly and you found your mRNA sequence, found your tRNA anticodon sequence, you should have used this amino acid chart to find the amino acids that were coded for. Now, one specific thing I do want to note is that whenever you're using this chart, you're going to use the mRNA codons and not the tRNA codons. Okay, so you're going to use mRNA, not tRNA. Right, so if you ever are a little bit confused, just remember that this title is always going to be on the top of the chart. It always says messenger RNA, and that's kind of your key to use the mRNA codons. Okay, so using those mRNA codons, I'll go ahead and do the first one as an example. You should have gotten CUU. All right, so let's walk through how to use this chart. So our first codon is CUU. This table is divided into 3 sections. On the very left-hand side, you're looking at your first base. So our first base was C. So the first row of this chart says U, second says C, then A, and then G. Since C was our first mRNA base, we now know we're going to be looking at this row of our chart right here. So our amino acid is going to be somewhere within this column or this row. Okay, but we're not done yet. So our second our second base is U. So that requires us to use the top of this chart to find the second base. So again, you see that it's divided into U, C, A, and G. And because our second base was U, we're now going to be looking in this row right here. But because we've already isolated that first base, we actually know we're going to be looking just within this specific box right here. Okay, but again, we're still not done. We still have one more base to narrow down. So that requires us to look at this third base. Oh no, go back. This third base section over here, right? Our third base is U. And if you look closely, you can see that this is arranged by U, C, A, and G, right? Our last base is G, is U. So I'm going to follow this U all the way across. Why is my line not drawing? Oh, it's a Friday afternoon and I'm collapsing. All right, we're going to follow this U all the way across to the box that we've already isolated. And we see that CUU actually codes for the amino acid leucine, or LEU, right? So that means that very first amino acid you should have gotten is leucine. So I'm going to fill that in. Okay. And you should have done these other 2 on your own. But in order to figure out what the protein was, this required you to look at the post I made on Google Classroom. Okay, so I'm going to go over to Google Classroom. All right, and I see that I made a post that says, if the amino acid sequence LEU, GLU, SER codes for insulin, and GLU, LEU, SER codes for hemoglobin, what was the protein from today's practice activity? So we've already figured out, or we've only figured out one amino acid, but using that amino acid, we can actually figure out what the answer is, right? Because I said that the first sequence, if it was LEU, that meant the protein being coded for was insulin, right? So the answer here for the protein being coded for was insulin. Hold on, there we go. Right, so the way that I arranged these amino acid sequences is if you used the mRNA sequence to find your amino acids, you would have gotten the correct answer. But if you used the tRNA sequences, which you shouldn't, you would have gotten that the answer was hemoglobin. Okay, but the answer there was insulin, which leads us straight into number 2. What protein does this DNA code for? You should have gotten insulin. Now, number 3, there was a tiny mistake here, but it shouldn't have affected your answer. So it says, if instead of ACT, the first DNA triplet was ACG, which amino acid would be coded for? So our first DNA triplet actually wasn't ACT, it was GAA, but that didn't affect your answer. All that I wanted you to do for this answer was to figure out what the mRNA sequence of ACG would be, right? And we know based on our base pairing that the answer should be UGC. So now, because we're looking for an amino acid, you have to use that sequence and take it straight back to your chart. So now the second codon we're going to look for is UGC. So I'm going to erase everything I wrote on this chart, and we're going to do it all over again. Right, so again, the first base you're looking for is U. So I'm going to go to the left-hand side of my chart and find my U, which means I'm going to be looking strictly in this row right here. Right, my second base is G. So I'm going to go up here to the top, find my second base, which I see right here is G. So that means I'm now going to be strictly looking in this box for our answer. Right, but then we've got one more base to look for, and that is C. So again, I'm going to look over here for the third base. I see here's a U, C, A, and G. So since our last base was C, I'm going to follow this C over here and see that UGC actually codes for cysteine. Right, so that amino acid would be CYS. All right. And, all right, I was just checking the answer. All right, the last one. What amino acid is carried by a tRNA with the anticodon GUA? So this one required you to know how mRNA and tRNA anticodons work. So we know that tRNA codons, or anticodons, I should say, are actually the opposite of the mRNA codon. So if the anticodon is GUA, we can go ahead and draw our tRNA molecule. It's attached to this anticodon and it's carrying an amino acid. I'm going to move this down if I can. Oh my gosh, that wind. All right, I'm going to redraw that so we've got a little bit more space. All right, so we've got our anticodon. It's connected to our tRNA, and that tRNA is carrying an amino acid. But we've got to figure out what that amino acid is. However, you can't just take this GUA anticodon to our amino acid chart because remember, we're looking for the mRNA sequence and not the tRNA. So this required you to know that the mRNA codon is going to be opposite of that anticodon. So it would be CAU. So now we're going to take CAU over to our amino acid chart and follow the same pattern we just did. Right, so the first thing you're going to do is look for your first base. First base is C, so I'm going to be looking right here. Second base is A, so I'm going to be looking right here. That means that I've narrowed it down to this box right here, because it's in this row and this row. Right, but we still have to look for that last base, which is U. So I'm going to look for my third base over here, follow my U across, and I see that CAU codes for the amino acid histidine, or HIS. So the amino acid being coded for is HIS. All right, and hopefully that explains the answers. If you have any more questions, please let me know. But other than that, have a great spring break, and I will see you later.